Hey guys, just wanted to do a presentation that I did last Sunday, or introduce you to the presentation I did last Sunday with one of my directors from my Human Performance Masters. We did a speech on integrating plyometrics into your program. I wrote the PowerPoint, and Dr. Daniel Dodd and myself presented to strength and conditioning coaches and basketball coaches. The reason why I'm showing you this is a couple specific reasons. Why it dives into the reason why we do plyometrics, and we do utilize them in both strength aspect and within MTT, both in kind of a different way. Two, talk about force velocity curve and how that's applicable to not only plyometrics, but also to strength training and lifting. And three, I think it's always good to have knowledge about all aspects of our field and the modalities in which we use in our field. So without further ado, here is integrating plyometrics into your program. The first thing we want to look at is, what is it? Well, it's a specialized exercise to prepare the athlete for specific and explosive movement. That is quoted by Dr. Michael Yasis, one of the phenomenal strength coaches for plyometric development abroad and within the U.S. Remember, plyometrics can be lower body, upper body, throwing, hopping, jumping, skipping. It does not just mean box jumping. It does not just mean broad jumping. There's many facets to plyometric movements that involves explosive movements. Okay, so you can make anything really plyometric. When we look at movements, I'm just going to flash through a couple of these. Tennis, application of loading that potential energy and then kinetically moving that potential energy. All right, baseball swing, another great example. Stored, releasing that plyometric energy. Again, puck is coming at him. He's loading that hockey stick, and then he's unleashing that energy like a rubber band. Block, LeBron James. I do not like LeBron James, but great block there. Look at that movement. Look at that explosiveness, the preparation, the loading, and then he goes right into that jump and explosiveness. Golf swing. If you watch her load that pattern, she's going to load with her backswing, and this relates just like we're jumping. She's going to load. She's loading that potential energy just like a rubber band. She snaps a rubber band, and the velocity is highest point right there. Then you look at Tiger Woods, another great example, and then Walter Payton. Talk about being explosive. All right, so looking at from Dr. Chu in 1983, Dr. Chu is the best in the United States when it comes to plyometric training. He actually flew all over the world to learn about this topic. Introduced in the 60s by Verkhoshansky, Russian base. I do have a video. It is not currently playing, but it is a video of how the Russians trained, and very applicable to the time of track and field in the 1970s, which was used as drills to improve speed, right? Because there's a direct proportion to speed, how fast you are, and how high you jump. And acceleration specifically, and top end speed. But it's using a dynamic method to improve power output. Verkhoshansky is a big proponent of depth jumps to absorb load and how to distribute load, which we will talk about in a few minutes here. This is the video, unfortunately, is not working. So the purpose, again, increase muscular power by using naturally elastic components of muscle and tendon in the stretch reflex. So what the NSCA here is saying is that we have a stretch shortening complex, right, where we have the ability, again, to store energy in our ligaments and tendons, right? Store, and contract them elastically like a rubber band, and take that energy that is stored and move it somewhere and be explosive. And that's essentially what our body is trying to do. And we'll look at it in the force velocity curve. So the heavier I lift weight, the slower the movement is, right? So if I'm lifting at 90% of my strength at the bench press, it's going to move slower than if I did it at 60%, right? So the higher the top left of the curve, when my max or velocity or force is at its highest, we're looking at slower movement, right? So the bottom left graph, right, is force. The top left is velocity. So when velocity is zero and the force is going to be higher output. Where if you look at power, right, as the power goes quicker, velocity increases to its max up at the peak, looking like a bell curve. That's as fast as you can go, and then it slows down as we go towards the bottom end of the force curve. Force, heavy resistance training, again, velocity and power directly proportional to each other. In order to increase our power, we have to increase our speed, so it's cutting down how fast we move the bar, right? It's called bar path. If I can move that bar path faster, say in a power clean from the floor to the clean rack position, the faster I do that, the more power I have. Generally, power is seen somewhere between 40 and 60%. Plyometric training. Aim, decrease the time between the eccentric and centric movements. Again, eccentric is that loading, concentric is the distribution of that load or energy. Maximize stored energy from the eccentric action. Look at the figure on the left. He is loading. Amortization, middle part, is the time it takes you to get from eccentric to concentric to that jump phase on the right, which is the concentric jump. The speed in which we do that is the speed in which, or power in which we have, which will allow us to jump higher and farther. This is what training in plyometrics can do. It can create a velocity curve shift. So we're shifting that force that you are straw on the bottom right and shifting it upwards and also increasing that power capability over time. So the better we get at something, the stronger we get at something while incorporating plyometrics or power in different various movements, we will get stronger at a faster rate, meaning the ability to bench press 300 pounds faster versus when we were weaker will be better, okay? Or the ability to jump higher over time will be better because we know how to distribute force, okay? Newton's law, equal opposites force react. So if I push pressure into the ground, that pressure is equal and opposite and should push me or apply pressure upward as much as I put in the ground. Again, looking at that bottom right. Common mistakes: 1, lack of understanding scientific theories, why we do plyometrics, how to apply them. Expense and adding intensity. So, people always think they want to go higher and crazy intensity. You don't need to do that all the time. Plyometrics for conditioning. Some, yes. Most of the time, no. Remember, nobody ever got hurt jumping. They get hurt landing. And as you tire the musculature body out, you higher for injury potential increases. So if I use this high CNS activity of jumping for countless times or a longer period of time, I have a higher incidence of getting injured because my nervous system cannot put up that much volume. Quantity versus quality. Again, we want more quality than we do quantity, and focus on force output instead of absorbing force over emphasis on inclusion jumps onto a box. Avoid, exclude, or alternate drops. So we want to really put an emphasis on proper landing mechanics versus just creating a high quality or quantity of jumps. Program design. So how do we go ahead and program this? Well, many different ways. It should be optimal output of stress, sufficient amount of recovery. We do not recover a lot. Hence, if any of you have seen any of my strength workouts, that power block, right, is used for a multi-joint movement, possibly supersetted with some sort of jump movement, and then a core movement. That core movement allows for sufficient recovery so we can go ahead and put the same output of work into the first two movements, okay? Obviously, that maximizes the training effect. Program design, we look at these 7 things: needs analysis, mode, intensity, frequency, duration, recovery, progression, okay? Every session has a cost, whether it's good or bad. Cost meaning energy. Cost meaning is A of my needs analysis meeting up with my progressions. There's always a cost benefit. Needs analysis, important for all aspects of what we do, specifically talking about plyometric training. Physiological and biomechanical requirements of the sport and or individual. Injury profile of the sport and of individual. Strength and weaknesses of the athlete and available facilities, equipment, and resources, right? So we have to know the physiological and biomechanical requirements of the sport. Physiologically speaking, what energy systems am I working? Biomechanically speaking, what body parts am I needed, or what do I have to be really good at in order to perfect the sport? Injury profile of the sport. So we're looking at the sport. What possible injuries do we see? So soccer, ACL, football, ankles, knees, shoulders, baseball, elbow, shoulder. So all these sports have all injury, possibilities, but some sports are more detrimental to one injury versus another. Strength and weaknesses of the athlete, that comes with evaluation. What are their strengths and weaknesses? Remember, we're only as good as our weakest link. Available facilities, equipment, and resources, that goes without mention. You have to work with what you have. Mode. How are we going to go ahead and do this? So what we have Working at depth jumps, box drills, bounds, hops, jumps, chest pass, overhead, side to side, catch and press, depth, push up. So we look at how we're going to sequence this, right? You heard me talk about sequencing a lot. Double limb, single limb, in place, vertical, horizontal, lateral, and rotational. Okay, so we have a lot of ways we can manipulate the plyometric movement and a lot of ways that we can't. So we look for that and we want to program it into such. Training considerations. Landing mechanics need to land with some noise. No soft landing on clouds anymore. We need those tendons to be able to absorb. Age and maturation. Look at their biological versus chronicle and also their training age. Okay, so their age might be 14, but they could have 2 years of training, right? So they might have a higher training age. Physical readiness. Are they prepared for what you're about to do to them physically in the realm of jumping? Equipment and facilities. Again, landing surface. Supervision, coaching, always supervise. Landing mechanics is a pretty funny video, actually. The ending's the best. Make sure we teach them how to land, because when they land poorly, at least she gives a nice little finish at the end. But we want to make sure we land like this. Always start how you land. Start with your hands back, land with your hands back. But you always want to start where you land. Both feet on the box is pictured here. Good weight distribution, knees in front or at the toes or just behind, chest nice and tall, eyes forward. Here is a version of me jumping here, if I can get this to play. This is a base counter movement jump, non-counter movement, so I pause in between. Driving those hips, landing how I start, push and drive, right? Here is a, excuse me here. Here is my other one here, if I can get this to work. This is a mini hop, so this is increasing or a level 2 movement where I'm adding some elasticity to the movement, okay? Regular box jump here by Jones. Remember, box height is not an indication of jump height. We want to make sure that we're landing softly. He is actually a heavy deadlifter in the 500-600 pound range. If this would work, this would be great. There we go. This was just a reminder of distribution of force and load and kind of prep him for his workout. How intensity volume. So how do we look at this? Well, we look at points of contact, speed of movement, height of the drill, weight resistance. All are intertwined, but we need to look at recommended landing, right? So beginner, 80 to 100 contacts per session, intermediate, 1 to 120, and advanced, 120 to 140. Most of your high Olympic level athletes will not do more than 120. Beginner, remember, every time you touch and jump, it is a contact. For instance, jump roping in one of our MTTs would be 50 contacts. It's a lot of jumping. Plus 10 box jumps, 60, plus doing that 3 or 4 times in a set. So we gotta be conscious of that, because as we do more and more and more, put more and wear on the body, thus creating potential injury. Program consideration, 4 to 10 weeks, be progressive overload, isolated and additional to resistance training program. Individualized, even in a team environment, can happen, very difficult to do. Be aware of fatigue and overuse. Gas syndrome, I have given you guys articles on that. General adaptation, Hans Seeley's chart for if you're overtraining. And include a sufficient warm-up, which we all know is crucially important. Here you go for the youth, in case you're interested. I'll zip right through these. Focus on eccentric loading, low to high intensity, volume, performance threshold, single to multiple sets of 6 to 10 reps, frequency 2 sessions or less, not consecutive, so we get rest, rep velocity, use performance thresholds to maximize motivation performance quality, and then recover 60 to 180 seconds as a guide. It also is based on your coach's eye. This is a great thing made by Lloyd. Lloyd is a great strength and conditioning coach. This was delved to us in 2011. Just looking at the bottom and working your way up, not a pyramid form, but progressive overload going way up. To the left, fundamentals, 6 to 9 years old, female 6 to 8, unrestricted play, fundamental movement skills. Level 2, learning to train, 9 to 12 years old for males, 8 to 11. Low intensity plyometrics, jumps in place, standing jumps. Move up to stage 3, medium intensity, multiple bilateral hopping and jumping. 4, medium intensity box jumps, obstacle jumps, so hurdles. 5, bounding. We're getting height and linear horizontal movement as well. And then obviously the last stage is drop jumps, and that's for elite athletes, 19 plus for males, 18 plus for females. Some resources, guys, if you're interested, Coach's Guide to Jumping, that is an awesome thing. Reach Your Potential is awesome. And then obviously Dr. Donald Chu, plyometrics, dynamic strength, and explosive power. I just want to give you guys this. I thank you so much for listening, And it's always fun giving out some great information. Thank you. Bye bye.